Hi, everybody. My name is Alexander Gard-Murray. I'm the Executive Director of Passive House, Massachusetts, and I'm really excited to welcome you all to our April monthly meeting. And before I begin, just a few logistical details. I'd like to start by thanking the sponsors of Mass Save for making this event possible and making this whole series possible. And I'd also like to highlight a few of the great incentives that Mass Save offers for passive house projects. There are single-family incentives, $25,000 for a single-family one-unit building and increasing for larger units. But as the topic of today's discussion and much of our monthly meeting series are multifamily residential, I'd like to particularly highlight the $750 Mass Save incentive for projects achieving tree certification with either FIAS or PHI, and then $3,000 per unit. Both of these are per unit after achieving certification, again, either with FIAS or PHI. And that's in addition to other market transformation adders. And if you're starting a passive house project or even thinking about starting a passive house multifamily project, the email to contact is multifhr@icf.com. And if you forget that, we're happy to remind you. They will get you started on the right track with your multifamily passive house project, accessing incentives and the like. Passive House Massachusetts is also always happy to help you in your passive house journey, providing training, accessing incentives, getting you to the right place. So please be in touch with us. You can go to phmass.org or contact me, Alexander, at phmass.org. And if you have more general questions about passive house incentives in Massachusetts, you can contact Passive House Training, MA@ICF.com. Last logistical things, if you are here in person, please make sure to sign in on the sheet we have back there. We'll also circulate it during the talk as well, and that's how we confirm attendance for CEUs. If people are online, they'll just record the name that's on your video as attending. For CEUs here, we have a QR code that's on the table that you entered, and we'll also share the link in the chat at the end of the event. So without any further ado, I would like to introduce Kurt Lamar of the Building Advisory Group and Chris Becker of Callahan Construction Managers. Kurt has been doing this particular job for 15 years, right? Passive house for 15, for passive house for 6, okay. And Chris has been with Callahan for 16 years and 11 months. So they're both bringing a wealth of experience on passive house projects. We're really excited to have them speak to us about the lessons they've learned.
Second,
Let's give them a round of applause.
Yeah. Thank you. Much appreciated. We appreciate you guys all coming out today to learn a little about construction hurdles and how to overcome them. When we go through the design process of FIAS, it's a little bit more prescriptive, and then when we get to the site, we all know what we're doing during the design phase, but then we get to the site, we're trying to get people to do what we designed, and sometimes that's extremely difficult. So what we're going to talk about today is some of the issues that we've run into in our experience and how we overcame them. We're also going to talk about some strategies that we use at Callahan and Kurt's used at the Building Advisory Group, and how to really execute well and keep quality top of mind, which is really important for our FIAS projects. So I want to start just by looking at the life of a project, right? Overall, we go through site work, foundations, slab on deck, framing envelope. There's components to each section here within FIAS, but we're going to focus today on framing, envelope, MEP, thermal insulation, and substantial completion. And with that, I'm going to hand it to Kurt.
Great, thank you, Chris. So this first picture is really for FIAS raters or verifiers in terms of the stud count. I've always found it interesting in multifamily construction that you know, if they're gonna assume that you have one stud every 16 inches, that's a drastic underestimation of the actual count of studs. On this bearing wall, you can see it's all double studs, triple studs are double, kings and jacks are all double. Solid LVL headers going across. So in just that wall assembly there, I'm guessing it's probably 30 or 40% reduced in insulation value. So if we can insulate headers, doors and window headers, it's recommended if the structural loads allow it. You can see that these headers here are thermally broken. Doesn't always happen, but it's recommended if we can do it, we should. This is one of Chris's projects in Salem. What Callahan found out was that by changing the exterior sheathing to CDX plywood, you no longer had to prime the OSB for your WRB. So it was a cost-effective move to change your cladding. Okay, we're going to the envelope. This project here, it's critical to always get your flashing, taping and membranes flat and flush. You can see in this photograph here, you've got wrinkles where there's going to be air gaps. So there's a chance that your window might not pass your air pressure testing due to the installation of this flashing. And here's a photograph of the way we would like it to look. On this project, all of the pre-flashing for the windows peeled away from the substrate. We never found out if it was due to temperature or moisture control issues. But every single window, the flashing came loose around the perimeter. So by waiting until the wood dried out, we installed primer around all the windows, and that allowed the pre-flashing to re-adhere to the windows. It also came loose on the head jamb and sills. And on these, a heat gun was used once the moisture content of the framing dried out and it was able to re-adhere. We had to have Briggs come in and do full tests to make sure the adhesion was correct. And again, just to make sure that our moisture content is correct for all the materials being installed. Consideration needs to be taken when installing the WRB. You can see in this photograph, there's wrinkles and gaps, bubbles. It needs to be smooth. So all of these wrinkles are potential air loss. So those would all need to be corrected. Again, another photo of how a deficient WRB is in place. So the substrate needs to be flat and flush prior to the WRB. When you have protrusions on your skin and they install the structural girts, there's a chance that you're gonna create a penetration through your WRB. So all of that needs to be smooth before the girts are installed. In this photograph, the mason was searching for studs for all of his anchors. So every inch or so, he'd drill a pilot hole through the envelope looking for the stud. And then your waterproofing contractor would have to come back and patch all the holes that he made. So this kind of issue is really resolved with communication. If your subcontractors understand the process and principles, hopefully they won't be doing this. Again, just a tear. So the WRB is so sticky that you can't just peel it off and reapply. When you try to peel it off, that's what happens. So it's a nightmare to try to fix deficient WRB. This photograph, the girts that were installed were in the wrong location. So the cladding contractor had to remove all the girts, and that left all holes in the WRB. So again, your waterproofing contractor had to come back and patch and repair every penetration that was made. Mock-ups, make sure that you get mock-ups for almost every system that's involved in your building. Make sure that all the material is procured well ahead of time, your windows, your clips, your cladding, because it needs to be done well ahead of time, so that it's an actual in-place mock-up of the true conditions of your construction. This window mock-up in Chicago was fiber cement boards, all pre-drilled, so the girts had to be in the exact locations. We spent weeks and weeks going through this window mock-up until it was done right. And we suggest that you don't do your window testing until all the cladding is done, because the cladding is gonna create more penetrations. So we always recommend that window testing is done after the cladding is complete. This is the same project in Chicago. It was, all the windows were installed in the factory. Brought out to the site, insulation was done, pre-flashing was done, windows were done. So you can avoid the issue that I showed earlier where all the pre-flashing failed in the windows. So for interior air sealing, typically use Fentrim tape that seals your window frame to your pre-flashing. But the Fentrim tape needs to be continuous, especially around the inside corners. Caulking needs to be done with care, needs to be tooled into the joints for a better air seal. You can see in that picture, that's not what we want to see for caulking. So when windows are mulled together, there's a chance that that mullion or the snap cover is going to create an air loss. So this is the top of the window head, and it was not passing our air test because air was getting down through our snap cover and through your window frame. So it's really ideal if you don't mull windows. You obviously can. Most jobs do have mulled windows, but your air testing is going to get better results when you have single pane windows. And this is the same picture at the sill where the Fentrim tape was applied to cover that snap cover. This window was removed and relocated, so you can see all the nail holes of where it was originally installed. It's gonna get taped, but it just leaves another potential for air loss. And keep in mind this window shim, I'll show you in the next photograph why that's important. So if that window shim isn't taken out, the Fentrim tape is just gonna run over it, and that's gonna leave a gap on each side of the window shim. Sequencing, all the WRB needs to be installed before your light fixtures, junction boxes, and any exterior wall penetration. You can see in this photograph, the contractor installed the light fixtures before the WRB was complete. So they had to take the light fixtures down, install the WRB, and then put the lights back up. And the same with this stair tower, where the MC cable was secured to the CMU without the WRB in place. CMU walls, every penetration should be sealed. So when you have MC cable or wires that are penetrating through your exterior wall, it's best to have one hole and one wire. Don't make a bigger hole for 2 wires because it's much more difficult to air seal. The windows are typically triple glazed in passive house construction. They're very heavy. And you can see that the way that these were being stored on site was putting a significant load on the window mullion, which could potentially affect the air seal and the integrity of that joint. Also, the dust and debris in these units will get into your windowsills. So typically, if you have that kind of debris in your windowsill, it's not going to close. It won't seal tight to the gasket. It's a potential for air loss. So when architects do your punch, it's important to open up every window and look at the tracks to make sure they're clean. Termination and protection of membranes and flashings. You can see in this picture that that was the finished condition. So the architects need to make sure that every condition, and there's a lot of them, is gonna be terminated and protected so that you don't leave these kinds of exposed conditions. And this photo is just, a liquid membrane on the CMU as opposed to the, peel and stick WRB.
All right, so just because it's installed properly the first time, doesn't mean that's not gonna get damaged over the course of construction. So you can see here, this is the corner of a building, it was a tight site in Cambridge. And what ended up happening is the skid steer drove by and clipped the corner just a little bit too tight, right? We noticed it. And the ABB installer went through and tried to fix it. And it might be hard to see on here, but you can see they fixed the C-grap, but what they didn't do was tie in the fence trim tape to the underside of the C-grap, so you still end up having the air seal issue, where you don't have the continuity between the black fence trim that's on the underside of the sheathing tying up into the C-grap. So just because they fixed it doesn't exactly mean they fixed it right. So we gotta make sure we're looking for the QA QCI in order to make sure we're doing it properly. Oops. Sometimes it's not quite as obvious. Sometimes we end up with material hitting the corner of buildings. We end up busting the corner up. And if we weren't looking up, we probably wouldn't have seen this. So again, just paying attention to the potential issues that happen after the material is already installed is extremely important. So the way that we do that at Callahan is we actually go through and we do a QA/QC inspection as soon as it's installed to make sure it's installed properly. And then again, right before anything is going to go and go over top of it, right? And we do that by, you can kind of see here, we take a marker. So on Sega, we can just take a marker. We actually go through and we get up on the lift or ladder or whatever means we need in order to get up and actually view all the different parts of the ABB, and we mark them up, and then from the ground, it's very easy to see if they actually completed all the patching that was required, right? You can see you got circles known as arrows. Sometimes I miss it, right? So again, it's important to do the QA/QC right when they install the product to make sure it's installed right the first time. But right before it gets covered up, if you don't make that last check, you're going to end up with situations where you have holes that you're never going to find. So I want to take this a little bit different route. So when I do passive house drawing reviews as a builder, there's two locations that I really look at, just make sure that there's continuity in the area. The first one is the trash rooms, and the second one, and trash chute, and the second one is the laundry room. So let's look at the trash rooms first. On this job, trash room is located right here in the corner of the building. And you can see this is the compartmentalization plan. So they excluded the chutes in this job, and the trash room is also excluded, which is excellent, right? So we take a closer look at the detail here. It looks like a pretty standard detail. As we zoom in on it, we see the air barrier. It's located on the inside of the chutes, kind of sandwiched in between the sheathing and the GWB, but that's a means and methods problem for us. But as we look at this, we have a seal that's on the inside where the trash chute door is. That's our main leak, right? And so there's a problem here. If I have air coming down the trash chute, it's going to make it up and into that cavity, and it's going to get into the ceiling, and then from there, who knows where it's going to go, right? I end up with an air leak. So when I'm doing drawing reviews, one of the first things I'm doing is I'm looking at the trash chute doors, looking at the trash chute continuity of the air barrier, typically at the roof, at the trash chute doors, and then as it gets down into the trash room itself, right? So how do we fix this? This is a super simple fix. We put in RFI in this job and it ended up working out great, but we're just gonna take that ABB and we're just gonna wrap it right in so that it hits the gasket on the inside of that trash room door. And then from there, it should eliminate that air seal leak. So let's look at another project. This is another project. This one's in New York. This is a 8-story block and plank building. And you can see on this compartmentalization plan that they didn't exclude the trash chute or the trash room in this building. Take a closer look. It's a singular chute with a singular compactor, but we look at the detail of it, and there is no ABB on the inside or the outside of that trash chute CMU. CMU is porous. You will get air leaks through it, I promise you. If you don't get them right away, as soon as that grout shrinks, you will end up with some sort of crack, which is an air leak waiting to happen. So we end up having this issue, similar issue to the other job, but right now, there's no provision in order to actually fix this. So as of right now, there's an RFI in to see what we're gonna do about this trash chute. Now, if we go down to the trash room, the first thing I'm looking at is the fact that that it is part of the compartmentalization, means that we need to make sure it's completely sealed. Well, on this project specifically, they have a motorized roll down gate. If anybody's tried to air seal a motorized roll down gate, it's impossible. Fun fact, right? So we go through and we look at these things and we say, hey, listen, this is not gonna work, right? As the builder, we want to provide you guys with a building that's gonna pass. And in our experience, there's no way to do it with the way that this is going right now. So the easy thing to do would be to exclude it, right? We can throw a 5 certified door on the inside of the trash room, seal that up, seal up the trash room itself, and not as easy as it fixes the first one, but still very fixable, right? So moving on to laundry rooms and dryer ducts, specifically dryer ducts are the problem because they vent directly to the outside. So there's two options here, and this job actually had one part, they had it excluded originally, and then they actually switched to including it. I'll explain that in a second, but if you're excluding it, right, they end up having ADB around the entirety of the room. And on this job, they actually had a fire certified door on the laundry room, which works great, right? When they moved it to be inclusive within the envelope, we ended up having to have a damper, electronic damper, so that way when the dryer runs, it goes out, when it's off, it shuts, right? So we don't end up with that loss. And just as a FYI, those are a pain to clean. If anybody's ever had to do maintenance on one of these things, they can be very difficult. So choose wisely on that one. Midpoint blower door test. So as we go through, it's great to do a midpoint blower door test, right? It's our way to make sure that we're kind of on track. We're only going to get worse, allegedly, right? As we go through the process of putting holes in the side and the siding, right? We're putting all the facade on. We're only adding holes to this building. So the midpoint blower door testing is extremely important, but it's extremely difficult to actually achieve, in our opinions. Reason being that the form of the building actually makes a big difference. So when we're doing our midpoint blower door test, envelope should be complete, roof should be complete, all the windows should be complete and detailed, all the storefront should be complete and detailed, doors hopefully are complete and detailed, although you might have a couple that are kind of outstanding. And if you're really crushing it, you got your MEP penetrations out, and those are detailed as well. Now, for this particular job, I looked through the schedule. This job's currently being built. In order to do this midpoint blower door test, at that time when all these things are complete, this section of the building is doing finishes. This section of the building is doing MEP roof inspection. And this part of the building, which is that finger that comes down the screen, is doing non-weather tight MEPs. So we have a wide array of work that's happening at this point, which arguably half the building is completely covered in drywall at this point. And so it's going to be really hard to find an air leak if we go and do a midpoint blower door test on this project when we're actually able to do it. I'll give you another example. This is that same project in New York, 8-story block and plank. The difference is because the form of the building is significantly different, right? We're not covering as much square footage on the ground, it's more of a vertical installation. We end up with a lot less issues in terms of how much drywall there's going to be. Actually, there'll be none, right? So we have non-weather tight MEPs coming in here, MEP rough on going here, and then fire stopping inspections here. This project has a very good chance of actually being able to find and fix any of those air leaks that might be happening inside the building during the midpoint blower door test. So if I put these buildings next to each other, you kind of see it's generally to scale here, but the form of the building makes a significant difference in terms of how we're actually able to accomplish this midpoint blower door test in a meaningful way so that we can fix stuff on the inside, right? On the project on the left, there's a firewall here And after talking with the team, it almost makes sense to seal up that firewall. And then you could do 2 midpoint blower door tests, right? We could end up having that air sealed off completely, or as best as we could. And then midpoint blower door test one side, and then midpoint blower door test the other side. And then we have the exposure of this, we have the exposed studs on the inside and the exterior sheathing, so we can do some work from the inside or from the outside. It's not a significant amount of additional work, but it is a significant amount of thought that needs to go in to make sure that that entire wall is sealed and the doors are sealed accordingly in order to make that happen in a meaningful way. Right? If we end up having all the leaks at the wall that we're trying to separate, it's not a really good test. Right? We want to make sure that we're doing a great job at that wall so we can see where the leaks are throughout the rest of the building. So now we're going to talk about MEP penetrations.
So one of the goals of Passive House is to increase indoor air quality. And I think that starts with clean ductwork. So I really think that HVAC contractors should fabricate all their ductwork off-site, protect it, and then bring it on-site. When we build them on-site, it all gets full of dust. So this photograph was a finished product. I removed the blue protective film to look inside, and that was the result. So the contractor had to come back and clean all the ductwork in the whole project. This photograph is the heat pump enclosure. They were trying to cover all the heat pumps with the blue film, but half the time it gets ripped off by various trades, and you end up with ductwork inside your plenum. So the notorious car damper. So same concern, the drywall contractor came in to route out that opening. All the dust went into the enclosure, into the car damper itself. So as that's operating, it's going to be blowing dust, and there's a good chance that the dust could compromise the operation of the car damper itself. So it would be great if all the ductwork could be run in straight lines, but we understand that that's not possible. But you can see in this photograph, there's significant areas where it's cinched, and you're probably going to get reduced airflow. This photograph is really just talking about compartmentalization. Fire stopping is commonly used, not just for fire stopping, but for air sealing as well. You can also see that the junction boxes are gasketed and the ductwork all has mastic on the joints. So air leak locations. So there's a couple elements in multifamily units that's a common challenge for air sealing, and the biggest one is the media panel. You can see that the back is totally perforated. So in order to air seal this, you need to seal the cavity, the stud cavity that media panel is in. So the drywall needs to be sealed to the studs sealed to the concrete and to the deck above. Same consideration with the electric panels. And again, just in terms of air sealing, junction boxes all need to be gasketed, and the putty packs in the back can seal the hole where your wire comes into that junction box. So passive house buildings are commonly podium style, which results with sanitary piping below the deck, so it's exposed to the weather. So we recommend that you have heat trace on all your sanitary piping and then insulation on all that exposed piping. On this project, the solution was to take dense glass and build enclosures around all the sanitary piping, and then take spray foam and seal all those enclosures to protect them from freezing. This photograph just shows that the plumber put his piping in right in line where the drywall is going to be installed. So he just stopped the drywall at the edges of the pipe. So I'm guessing the plumber had to come back and move his pipes down. thermal insulation. So when you have podium style, you're gonna have thermal bridging on a lot of your columns, posts, and braces. You can see in this photograph that stainless steel bolts were used. It has a much better thermal resistance than the 8325 bolts. But the problem with this is that that thermal break was 2 feet below your insulation. So this portion of the brace is going to be exposed to the cold weather. So it needs to be within your insulation cavity. And one of these costs about $3,000 or $4,000. So not only is it a waste of money, but it's not efficient. So regarding exterior rock wool, we need to make sure that the rock wool is tight to the face of the sheathing. You can see in this photograph that it's falling off the face of the building. And when you have that much of an air cavity, this rock wool is no longer providing any thermal resistance in that wall assembly. We also need to make sure that it's installed and cut clean. There aren't gaps, rips. The installer needs to understand that it should all be cut to fit square edges and clean pieces. So this photograph is just showing that some rock wool is mechanically fastened and others is just laid inside the girts. My personal opinion is that none of it should be friction fit. It should all be mechanically fastened. Because while it looks good there, you can run into situations, this is difficult to see, but the rock wool does not fill the cavity of all the girts. So there's a 2-inch gap at every one of those girts. And if you took that across the entire building, there would be a significant thermal loss. Here you can see it better. So from the outside, it looks fine, but it's just not filling the entire cavity. And inside corners as well. Again, quality install, it should all be class 1. Another photograph of a poor installation. Same with fiberglass batt insulation. It shouldn't be over compressed. It should be cut to fit snugly within the studs. Another picture of it just being over compressed. And a lot of these issues would end up being revealed during the thermal imaging process at the end of the project. And you don't want to jeopardize certification after all that with poor insulation. Mechanical roof curbs. So we should carry the same roof insulation that we have across the roof deck through all of our curbs. This is a thermal loss if we don't do that. And I know that from past history, a lot of details don't show roof insulation being continuous through the curbs. And then even the refrigerant boxes need to be insulated as well. So just a quick story on this project. The shunt trip on the door malfunctioned. So this ERV was serviced. When they shut the door, since the shunt trip wasn't working, the ERV did not start. So for 3.5 months, the ERV did not run and nobody knew about it because there was no notifier, there was no auto dialer. So something to think about when we specify the equipment is it's best to have some type of notification that the equipment is running and operating properly. This project halfway through, Eversource told us that we could not export power back into the grid. And I guess it's shame on us for not confirming with Eversource that that was the case. So we had to redesign the solar array, engineer basically a backflow preventer to prevent any power from going back into the grid. So it's just a frustrating circumstance. EV charging stations. It's important for architects and owners to understand that EV charging stations are not in our energy model. So if you want to see how your building is performing once it's fully occupied, you need to take out the power from your EV charging stations from your power consumption.
All right, a couple of things that we run into on the construction side for substantial completion, the balancing at the end of the job, making sure that you have the low flow hood. This tab, person did not have that, and they ended up having to go out and get one, in order to complete the balancing of this building. We also had volume dampers on the diffusers, which was not ideal either. We were having a hard time getting the proper readings and being able to force the air back down into the first floor. And last but not least, obviously the blower door testing. This is for compartmentalization. I didn't have a picture for the full building, but just making sure that we are making, telling the trade partners that they can't be entering and exiting the building. I know it sounds silly, but they're not thinking about it. They're not used to doing blower door tests. They don't understand the impact. So making sure that they really understand that, hey, this is happening right now. You cannot walk through the building, even doing it on a weekend or just shutting down the job entirely, so this work can be done, is a good way to do it. So we talked a lot of problems, a lot of issues that have come up, right? And so we want to talk about some strategies that we can utilize for success. So here we're talking about creating clarity and alignment. The best way to do anything is, as a team, is to create clarity and alignment among all the team members and individuals. So say we have a starting point and we have a goal, right? At some point, the lead super in this case might know exactly what it needs to happen to get to that goal, right? They're team member number one, they're driving directly towards that goal. They try to tell team member number two, they kind of understand it, but they're not exactly going towards the goal, right? Team member number two is talking to team member number three, and they completely missed the memo. Right, we're going backwards. Really not ideal. What does that look like? I have a couple of examples, but the one we use here is for compartmentalization. There was a shear wall. Electrician said, I got a sawzall. We'll just rip a hole open, it'll be fine. They did this throughout the entire building, and it was a massive problem because no one caught it ahead of time. So what does that mean? Well, a lot of extra labor, time, materials end up getting put into fixing all of this and putting wood glove tape on all these different locations and putty packs on the back to make sure that we passed. So that's what team member number four had to do. And look how far away we are from our goal, right? All these lines are level of effort. Now, if we had clarity in line, if team member number one was able to articulate exactly what they required, right? Although team member number two might not go exactly the same direction, they're going much closer. Same with team member number three, right? Again, they're not going exactly the same direction, but they're going towards the goal, which means that when they don't rip up all of the sheathing, put that electrical box in, we're going the right direction. And we can then focus on other things to get to that goal easier, more efficiently, right? All these lines are the same length. We consider these all to be the same level of effort. It's clear that when we screw up, which obviously makes sense, but if we screw up, it costs a lot of time, it costs a lot of money and a lot of effort. So how do we create this clarity and alignment? The first thing we like to do is hold kickoff meetings. A lot of people are new to FIAS. They don't entirely understand what air sealing is. What I like to tell them when I do these meetings is we're basically trying to put a bag over the building, right? We're trying to air seal it, make sure that there's no holes in it. So we have a nice tight building, and then we mechanically bring in the fresh air. So we have those with the trade partners. Sometimes they're in the trailer, sometimes they're out on site. If we have a tricky detail, we want to get out there, and we want to point to it and actually talk about what exactly needs to happen. We maintain signage throughout our building. We happen to have it in 3 languages. We have it in English, Spanish, and Portuguese. And we also mount these to the lifts. The people that are most likely to put holes in your building are the siders and the masons and the people doing your facade. If they're up on a lift and there's a sign in the lift that says, hey, don't put that hole there unless you're gonna fill it, they're less likely to make that damage. Identifying verifier inspections. This is a huge one. Coordinating verifier inspections is extremely difficult on the construction side. Sometimes things move day to day, and we need to give a week's notice, possibly 2 weeks notice, depending on the verifier. So what we use is a visual schedule. This is something we've kind of moved to recently, but it's clear as day when you need to be there, and you can kind of see here, the green and the red here are the inspections, and each one of these cells is a day, is a date. So when they come on site, this is posted on the wall, this is given out every week for a 6-week, and it's clear as day where we expect the verifier to come and what they're going to be expecting exactly on what floor. And last but not least, and I can't emphasize this enough, having open communication and trusting that we are not just throwing stones with our reviews. What do I mean by that? We're a team. We're all trying to build the same project. We're all trying to be profitable on it, right? We're not trying to be a pain. We're trying to get this done together. So having that open communication between the design team, the ownership team, the trade partners, right? We all want to do this together. And if I go back to that clarity and alignment with the goal, what we're trying to do is do it efficiently and effectively, right? So if there's anything you take away from this, that open communication, and which is really trust, that we're all trying to get to the same place, is extremely important, and conveying that trust to other people. And with that, we're going to do Q&A.
Thank you so much, gentlemen. We're gonna alternate between Q&A in person and then people remotely over Zoom. Is there someone in the room that wants to start us off? Over there. Excellent. And if you can introduce yourself, Carla.
Carla Butterfield, Steve Winter Associates. Can you go back to when you said that you used plywood CDX instead of OSB because you didn't have to prime it for the vapor barrier? And then you did also have a picture of windows where flashing didn't stick, where you said you had to go back and prime. Was that also CDX?
No, that was plywood. Is that what you?
That's way back there.
Two parts of the question,
I'm sorry.
sorry. So if you're using plywood instead of OSB, you don't have to prime before you put on your,
It depends on the manufacturer.
okay. So could you tell us which manufacturers you were working with when you didn't have to prime? And then could you also explain why you had to prime for the flashing to stick around the windows?
So I don't know with regards to the CDX and the OSB. I don't know, that's still in, like, that picture is 2 weeks old. So I'm not sure what WRB we're using.
So on that project, we're using SIGA. On that project, we're using SIGA Magvest 500. So I've been to this, I went to Switzerland to the SIGA conference or whatever, and the primer is really necessary on the OSB specifically because the OSB is stranded, right, and it pulls away. And it's not a smooth, flat surface. That's the real problem with the OSB versus the plywood, is the smoothness of the surface. Because you get more contact with the plywood versus the CDI or the OSB.
And sometimes you can just ask them to reverse it, one side of
Yes,
it,
true.
instead of the other side.
But for all the pre-flashing that failed, I still don't know what the problem was. I mean, it was either temperature or it was moisture contact. I mean, I assume it was done in the winter time. We didn't get it all corrected until springtime when it dried out and warmed up.
Okay, now we have questions online.
Kurt, can you go back to some of your slides showing the Roxol insulation with those girts on the outside and how you have those gaps? So one of the questions that was just coming up as you were presenting that is if those were metal girts, and I was also a little confused looking at those slides and like, because this is important, I believe, to go through and talk about this detail, is if you could explain a little bit more what's going on with that particular exterior insulation detail, that'd be great.
Yep, so again, I don't know the cause. I'm guessing that the girt was not installed at 24 inches on center. And that maybe it was 26 inches on center.
Do you know the material of the girt?
It's aluminum with a thermal brake clip.
Oh, the girt.
Yep.
You can kind of see here the blue of the clip.
Anyone else in the audience?
Thanks. Excuse me. My name is Matt Filteri from SGH. I had a question about how you evaluate the schedule for the midpoint blower door test. I thought that was a really useful series of slides. Particularly if the suggestion to make a firewall a compartmentalization barrier where it doesn't necessarily have to be other than to achieve a midpoint test. How often are you seeing proposed modifications to interior assemblies to help an exterior envelope test come up during construction, whereas like I was looking at this from a design document standpoint before construction, that could be defined and written directly on the drawings. From a design standpoint, doesn't seem like a huge change. It just depends on when that suggestion comes up. And then maybe follow-up question after.
Yeah, sure. So to be honest with you, we stumbled upon this when I was doing some reviews with one of my teams on this project in particular. So in terms of the schedule question, what I did was I went through, and again, with the visual schedule, it's super simple to see when's weather tight, and then from weather tight, then looking at when are the doors going to be installed in the storefront, because sometimes that doesn't quite line up because it's typically on the first floor. So we go through, we look at that, we pinpoint that date, and then I basically draw a line up and see where every zone of each floor, where it's at, to figure out that graphic that I kind of put together earlier. So again, I think the building form makes such a big difference, and the reason I think that happens is because the roof is such a large driver, right? So if you have a smaller footprint, but it's more vertical, obviously you gotta wait for the roof to go on, right? Whereas here, I can put a roof here, roof here, roof here, and not have anything over there and be working in all these zones, right? So that's the big part there. In terms of the firewall, same conversation I was having with them, because we were trying to figure out how do we do a midpoint blower door test and have it be meaningful, right? We want to be able to access that back side of the wall. We don't want to have to do everything from the outside, and not to mention, we're gonna have facade going on over here before that midpoint blower door test happens, right? Which is, again, not ideal if we have a leak in that location. So we were spitballing, and one of the supers came up and was like, hey, listen, we have a firewall on this project. If we were to just tape the firewall, seal it to the deck, seal it to the, exterior, it'd be simple, and it's really not that big of a lift, all things considered. So if we were to do that, it would make it so that we could test one side versus the other. Does that answer your question?
Yeah, it's helpful. You also had a list of a few items that you were like, these are the critical items that we want to see complete in order to make this.
Yeah, these are the
I
envelope.
think you also mentioned any key penetrations at the exterior if you're really ahead of the game.
If you're crushing it, right, and obviously in this area, we would have to have them done already. But we found that one of the largest places for leaks is MEP penetrations, and surprisingly enough, it's not that, duct coming out of the wall. It's the electrician that comes in and just pokes out a Romex, right? Or they do a little bundle, which is always a problem. So if you're able to get those in ahead of time, awesome. The more locations, the better. But if not, it's not an end all be all, but you gotta be much more aware once you're doing that work to make sure that you're double, triple checking it before you start putting up the cladding. Because again, you don't want to have to go back in afterwards. We've had to do that before. It is not fun, especially when there's someone in the unit.
Yeah.
Right, so really not ideal.
Are the temporary ceiling requirements for anything that's not complete at the time of the midpoint blower door test, is that typically carried under GC, or are you looking to a specific subcontractor to pick up that assistance?
It depends on the job. So if we have someone that's really qualified or has done passive house before, and they understand what the requirements are, what we're trying to do, because at the end of the day, that midpoint blower door test is really just a quality check for us to make sure that we are on track, right? And that we don't have this massive hole somewhere that we don't know about. So in terms of who's doing it, we want someone who knows what they're doing, right? And so I've had jobs where I've ended up taping the floor, the seams on the plywood floor, because there was an overhang that went down, right? And I sealed all that on the top side and then put the flooring over it, right? And so same concept. And we physically did that as Callahan. we have one of our assistant supers go and do it. But then I've had other jobs where we just get the AVB, WRB person to come in and take care of it, or sometimes you can even tape it, depending on what it is that you're doing, like drywall, like mud and compound.
I kind of want to bring you guys back just to talk about midpoint air barrier testing because there's so much to cover with this. I have a different question coming in from the chat. Luke McNeely is asking if anyone is seeing or specifying whole building infiltration testing on non-passive house buildings. Sort of a general question about what's the trend in the industry, what are people seeing and specifying?
I have not.
So in-house, we have, as Callahan, we have our own blower door system. We have a HERS rater that's in-house, and we do compartmentalization on all of our buildings to make sure that we're meeting that requirement, but also they work with all the testing agencies that we have come on site. We don't typically do whole building blower door unless it's required, because it is quite a lift at the end of the day. And so we kind of keep it to the compartmentalization of the individual units.
Sharon Rolls, FD Winter Associates. I was wondering, yeah, I looked at your diagram where you were showing team member 1, team member 2, all the discontinuity. As a passive house verifier, we host some trades trainings, and you mentioned that you do an educational component for each new trade you bring on board. Can you elaborate more? Is that like reinforcing that trade training we have to make sure it gets trickled down to everyone, or how do you make sure that education goes to every single person who's installing anything in the building?
Yeah, so ideally, we're actually having the entirety of the crew that is going to be on the site going through this training. And we're not doing a really in-depth building science style type of training. What we're trying to say is, listen, guys, we're trying to create a high performance building. And in order to do that, here's all the different components that are associated with that, right? Making sure that we're not destroying all the thermal layers, making sure that we are air sealing as much as possible. If you make a hole in there, it's not a problem. You just need to let us know, right? And making it, it's not a, pointing fingers thing. It's a, hey, listen, as a team, we need to accomplish this. And if we accomplish it together, it's going to be a lot better for all of us. And so again, I kind of talk about the fact that we're trying to put a big bag around the building, essentially. And that makes it a lot easier for them to understand, like, hey, if I just poke a bunch of holes in here, it's a problem. And so I've had jobs where they try to basically say like how much area is allowed for leakage, right? I had a job where it was like, hey, we can only have a softball. And when you say that, they're like on the whole facade, you can have a softball size hole. That's it. And they're like, yep. And that really puts it into perspective for them to understand this is a thing. This is really important that I pay attention and really understand what I'm doing. And the training is different, right? On the envelope, I'm going to spend a lot more time on the AVB, and with the foundation guy, I want to say, hey, stop messing up my foundation insulation, and don't put holes in my stego wrap that you're not gonna take, right? Like, there's different aspects for each trade. It is new for us. We are starting to roll it out now. We're in the process of making a book of lessons learned and that type of stuff. So as L&D, that's where I'm really working towards, is getting all that completely done, so that way we can kind of transfer it between projects. So.
Yeah, so Joshua Klein is asking, and I know that you guys are working, I believe, at least on some PHI projects, not just FIAS projects.
Mhm.
So for construction verification, FIAS requires verification, always has, but for PHI projects currently does not require verification, even though it did recently introduce a verifier type certification. So here's the question. Have you seen an increase in demand for verifiers for PHI projects, Passive House Institute, or a potential future requirement for this role, considering the importance of it? So I know that neither of you are representing PHI, but your best stab, or, and I know we have some other folks in the audience who might also be able to weigh in on this.
I don't know the PHI requirements.
So I've worked on, I'm currently working on one PHI project and kind of working through it. It's not my forte by any means, but I will say that we do have projects that we're working on where we are hiring out an envelope consultants to kind of take that role on and help us with our QA/QC. So that way we're not solely the only ones looking, right? So we've hired BEA a couple times to try to help us on our projects, be a second set of eyes to help us really identify where are those leaks, where are those issues that we have. We're taking it on ourselves and we're paying for it ourselves because in our mind, it's a way to make sure that we are providing a quality product and that we're gonna pass it the first time, right? That's the goal. You don't wanna do it twice. I've done that before. It's miserable.
Is there any other questions from the audience or, yeah?
Do you run into situations where you pretty much finish the building, and still have some major leaks, you can figure it out? Can you have an example? Okay.
Storefront is very different. The storefront is very difficult to air seal. We run into problems with the doors, the gasketing, the way the frames are tied into your exterior wall assembly. But that's the troubles that I've seen for the most part in terms of the final blower door testing.
I haven't had any major issues with final blower door tests, but I have had some pretty serious issues with duct pressurization and making sure that we get the balancing to work because the system was so tight in terms of the CFM that we had to basically squeeze out every single one of them. And so we ended up bringing in people after the fact and aero sealing everything, and that was a lifesaver. But yeah.
And Stephen is asking, do you have a dedicated site control person? I think he's referring to like an error specialist every single day to keep up with trade penetrations.
Yeah, so we have started to, on the two projects we have going, we do have a passive house super is what we call them. And their entire role is dedicated to making sure that all the air sealing is being taken care of, all the duct pressurization testing is happening during the rough and not too late. Making sure that there's no issues with the thermal insulation, that all those transition details are being kind of accounted for. We just hired someone on the job that we have in Salem, and we have someone already on our job that's PHI technically, but 52 New Street. We have somebody that's there for that.
Now, and I was gonna add, as an answer to the last question, Ken Levinson from Passive House Network added in the chat that PHI projects do require verification. I think we have time for one last question from the audience, if anybody has one.
Alexander, if I may.
Maybe to evaluate the reliability of sealing, not the quality at the time you check it, but the construction mechanisms that fail over time to make sealing incomplete later in life.
Sure, you're talking about just aging of the ABB materials?
Yeah.
Yeah, so it is a great question. There's a lot of testing that happens. I know, again, I'll say SIGA because I've been over there, but they do quite a bit of testing on what happens over time, UV, right? UV exposure, that ends up being a pretty big problem on the bituminous products, right? So yeah, I mean, there's definitely issues depending on which product you go with. Obviously, I would ask the question to the manufacturer specifically and get some compatibility tests done as needed, because compatibility actually has been one of our biggest problems recently on a lot of our jobs.
Yeah, quick follow-up.
Yeah, sure.
The idea that there could be construction techniques that create reliability problems later that they pass like crazy, but then systematically you're just making it less reliable for life. I didn't know if you had encountered scenarios like that. Thanks.
Honestly, I have not.
Yeah.
But that doesn't mean I won't find out 10 years from now. So, hopefully not, fingers crossed, but.
Well, let's all wish Chris's projects well, and let's all a big round of applause for Kurt and Chris.
Thank you.